What does neurofeedback do? Neurofeedback is a form of brain training. The first premise is that behavioral symptoms or psychopathologies relate to physiology, that is, the wiring of our brain. Some examples of this are PTSD, when we're ruminating about the past, worried about the future, have bad sleep quality. Our PCC, our posterior cingulate cortex, is not metabolized adequately. fMRI studies by Rutlenius have shown this. Autism is another example where auditory and visual sensory processing areas of our brain are hypermetabolized. And bipolarity, or mood control issues, rely on prefrontal dopamine centers, which is our dorsolateral prefrontal cortex, which is a dysrhythmic in these cases. There are over 50 functional brain areas that deal with our sensory interpretation, our behavior, decision-making, action planning, and implementation. Some examples are the back of our head, parietal and occipital, which is very visual. There's areas dealing with spatial awareness, social emotions, personal and social boundaries, analyzing faces and body shapes, monitoring consequences of actions, anger, frustration, self-harm, inhibition, taking on different perspectives. It's an important one we'll deal with in another topic. Motor planning, self-other differentiation, reward monitoring, and motivation. There's a scientific basis for all of this. What happens is we give people psychological thought experiments, put them in an fMRI scanner, and see which brain areas activate differentially. There's 200 reports per year coming out on this, so it's very much an alive subject. What we're looking to do is assess which brain areas are performing or are dysrhythmic. A QEEG brain map does this. What we do is we measure the slight current on our scalp, which we can record, disaggregate into frequency bands, and analyze the communication of that brain area with other brain areas, and then compare this to a healthy norm. Ideally, this shows us performance by Brodmann functional brain area, and the other aspect of this is what we define as a norm or functional, but that's another topic. Then we look to train better behavior or functional connectivity. Enter neurofeedback. We start with a reward. The person is watching a movie of choice, anything that engages their conscious mind. The content is not relevant. What is relevant is the interest and engagement. Real-time measurement and analysis of brain behavior at the particular area we're looking to train occurs through wearing 3 or 4 electrodes at that time. When there's a suboptimal frequency pattern, and again, that's another topic, the volume changes slightly and temporarily. It's not stop-start. We can also vary the picture size or give tactile feedback. While our conscious mind is focused on the reward, the movie, the slight inconveniences posed by the feedback, as in the volume changes or the picture size changes or the tactile feedback, that's enough information for our brain to understand and change its behavior to avoid this inhibit. With repetition, or operant conditioning, that's the technical term, we can consolidate this more efficient behavior pattern. We see a learning curve occurring within session. Important to note is that these are pre-conscious processes. Our conscious mind only watches the movie. We're not trying to do anything, and that's ineffective. Showing the brain more efficient behavior, it's likely to accept this and integrate it into our social interactions and life in general. This is an organic process. The brain can choose to accept the new way of doing things. Chances are it is, because anything that's more efficient is good. And the process is non-invasive, as in nothing goes in. The sensors are merely recording an electrical signal. Nothing goes into the brain. The feedback is purely through perceiving the changes in volume and picture size or tactile feedback. What's more is we can measure the changes. We can see the cognitive improvements, what we're looking to address. We can also do a remap. So we do another brain map and we see the before and after changes, which are lasting, and again, that's scientifically proven. Our brain controls us, which means that this technique has a wide application area, starting with things like sensory integration, going on to behavioral issues. That's particularly important with kids, for example, anger, rage, self-harm even. We then can address our sense of self, improve our feeling of grounding. Social cues, social integration, and reading emotions. There's brain areas dealing with that, which we can train. Particularly relevant is focus, planning, sequencing, addressing distractibility. There's also mood control and motivation. Sleep is an important one and responds very quickly. Obsessive thoughts, and repetitive and intrusive thoughts, unwanted thoughts. We can help clear our general thought patterns. To more physical aspects such as neurodegeneration, we can see in early stages Alzheimer's and Parkinson's have EEG signatures which we can detect. We can also pick up on concussion or mild TBI. And with neurofeedback, we can aid the rehabilitation, again, in a proven manner. Thanks.